with what we will discuss about the Python in overall in our sessions. Okay. So we have already discussed that by and large the Python it is of it does two works. The first one is Python as a just a language which consists of set of rules, and other one is an application which actually does some work. So here by and large we will discuss only the theoretical aspect. What are the set of rules that this language has, and what are the rules that we have to follow if you want to communicate with your machine in Python language? That's what by and large we'll discuss. Okay. So now, so Python, if you see in totality, or if you see it in a bird's eye view, so Python consists of only 7 components. So that is, so these are the seven components. So if you sum it up, or if you look at a Python from a bird's eye view, so these are the things. If you cover all these things, the Python as a language is over. Then application, dealing with an application, working on an application, creating a lot of other things is a different aspect. But Python, like English has a grammar book. English has a set of rules. English has verbs, tenses, parts of speech. So like that, Python has a set of rules. These are those rules. If you cover all these things, then Python as a programming language is over. So out of which today I plan to discuss the initial 3, and next time we can discuss the remaining 4, because the initial 3 are fundamental blocks of Python. If you are clear in that, you can do anything with Python. So so basically Python consists of Python. Everything in a Python is an object, that you remember. First you remember that. What is object we'll see. But everything in Python is an object. It revolves around object only. Everything, every statement, every operation revolves around object in Python. So that's why we'll start with object. Then after that we will enter into statements and syntaxes. Means how will you write those syntaxes and how it is different from C and Java. Okay. And Python objects, then syntaxes, then we'll go to the functions and then modules and classes and object oriented program. And finally, after knowing all these things, we'll see the exceptions and tools. Okay. Now, like we will go what all topics we are gonna discuss in each part. We'll just look into that part. So if you see, this is in hardware architecture. In hardware architecture, we'll just discuss. It's like a brush up on what is RAM, ROM, processor, and how it works, and how it is connected with our Python, and how Python files communicate with our machine, and what is bytecode and what is machine code. And second one, we will look into object types. We have already discussed that Python is all about objects. So now, what are the objects that are there as of now existing? What are the fundamental objects or core objects? We call it a core objects. What are the core objects of Python? That we'll see. These are the things. Okay. Numeric, strings, lists, dictionaries, tuples, files, sets, and booleans. That's it. And next thing is statement and syntax. So here we will discuss what type of statements are there. Assignment statements or expressions, prints, and after that we will enter into if tests and syntax rules, and while loop, for loop, then how this break, continue, pass, and else can be used in your loops. And finally, the most important and thing is iterations and comprehensions. In addition to that, we will also discuss about the map and JIP. Okay. So then after completing the fundamental blocks of Python, because see, you are covering object, you are also covering the how these objects can be written, the semantic rules or syntax rules. Once you covered up all these things, then what you can do is you can build a function. So that's what we'll do. What is function and what is polymorphism and what is scope and what is argument? What is the difference between argument and parameter? Then once everything is ready, once functions is ready, object, you have an object, you have a syntax rules and you have function. Then what else you can do? You can build a module. So then we will enter into the most important one, that's a classes and OOP. So what we have said initially at the beginning of our session, we have said Python is all about object. But who builds this object? That's the question. That guy is a class. So that's why we will see in a sequential way. So we'll start with object, then syntax, then function and module. So to build this object, you need a class. So then we will enter into classes and we will build our own objects and own functions, own modules. So in classes and object-oriented program, there are some specific topics to that: inheritance and instances, operator overloading, overriding. Those topics also will cover. And finally, we will see the exceptions and tools, because we have seen all. So now what we have to do in case if you get any error, in case if you get an exception, how will you deal with it? That is the important thing. So that's why if you have knowledge of all these things, then only you can work with exceptions and errors. So here in the last part, we will deal with the exceptions and tools. So this is in totality what Python is. That's it. Nothing else. As a Python, as a theoretical programming language, this is all about, nothing else. If you want to add, if you want to increase, if you want to do something else, if you want to apply to make something new, so then you have to learn some other libraries, some other frameworks. But as far as Python concerned, if you take it as a language, a programming language, this is all about, nothing else. Okay. So now we will enter into the hardware architecture. Is it visible now? Changed?
Yeah, yes.
So now, so we have discussed so the first part. So before to work on Python or to use Python, you should know how Python works, because see, there are different aspects. You're a human, you know a separate language, and machine knows a separate language, and Python itself is a separate language. So there is a lot of things, lot of components are actually involving in this transaction. Okay. See, when you are saying something, the machine should understand, because you are giving commands or instructions to do something. Finally, you have to get some output. So that's why before you enter into actual language, actual programming language, we will see the hardware and how this hardware communicates with you directly. What is the interface in between? That's what we'll see. So we'll see initially the generic computing components. The computing components are nothing but which we use to do some operations. Computing is nothing but to do some operations. So here will the bare minimum requirement for the computer is a CPU. That's a central processing unit. CPU is nothing but our processor. So that processor, it consists of transistors. So that transistors actually do processing. Okay. Then we have our main memory, or we call it RAM. Okay. So what is RAM? RAM is a main memory. So here it stores data for a certain period of time or while your laptop is on. So once your laptop is off, obviously it goes off. But that transaction takes place means every processing. See, because if you want to process something, whether it is a word processing or it is image processing or video processing, whatever it may be, it need to be stored in some space. Because see, processor, what it does processing, maybe numeric calculations or that sort of work it does. But you have to store na somewhere. That place is a RAM. It's not a permanent storage, it's a temporary storage. But to do processing, the data should be stored and it should go to the processor, and then again it should be stored. Then only that transaction takes place. So that's our RAM. Then we have input devices through which we actually communicate to the CPU. We tell our processor to do something. You do this calculation. You do this word addition. You do this image addition. So these kind of things. And finally, through that output device, we will look our display. So and here the most important thing is ROM. That's a secondary memory, basically our hard disk. So here permanently the data can be stored. Okay. So now in summary, CPU, your processor processes the commands that you give. Your RAM stores those commands temporarily, and you use input and output device that to give your commands to the processor. And if you want to store all these things, that you have to use secondary memory. So now let's just like not too much, but a little view on processor. So basically processor is made up of a transistor. It is actually based on the metal of silicon. So transistor is maybe PNP or NPN. So basically how processor works, how this transistor work, that's what we have to see. Because silicon is only the silicon and few germanium, these are the only semiconductors. Remaining or not semiconductors, they may be conductor or insulator, but this is semiconductor because of their electronic configuration. If you see the last orbital orbit, that's a p orbit. So how many electrons you have is two only. Say normally 1 is to 2 is to 3D, 3p and then 3D. So p should be 6 and d should be 10. But here you have only 2. That means remaining 2 shells are empty. So because of this, it is neither conductor nor insulator. It is a semiconductor. When you excite, when you give some energy, then obviously the electrons excite and moves. When electrons is removed, then it can be converted into either conductor or insulator. So that's the benefit of this. That's why we can use it as a transistor. Now this is the schematic representation of our transistor. So it will have a collector and emitter and base. So for us, a transistor is like a simple switch. Okay. So when you supply a power in a layman language, you can either allow something to go on or something to be stopped. So that means you can have only two states, So 0 or 1. So that is the reason with the 0 and 1, with two states, you can do processing. Because with those two states, you can create AND gate, you can create OR gate, you can create NAND gate, you can create NOT gate, you can create NOR gate. So with these two states, you're doing almost all processing in your computer. So for us, this is the most important. So basically, this processor itself consists of some 4 components. One is ALU, that's arithmetic logic unit. So this takes integers, INT, integers, and it does all mathematical operations with integer, and you will have a floating point unit. It takes floating numbers, that's 1.2, 2.3, these kind of numbers, and registers and cache memory. So now in registers, these are for the special applications, and cache memory is also for something for other application. So now it's RAM. So RAM is also again in an integrated circuit made up of million transistors. We have already discussed that transistor is a semiconductor. Maybe it is a PNP or NPN. So that's the reason it actually, see, when you can process with the on and off, you can also store data with on and off. Okay, that's how this RAM works. That's how it stores the data for some time, not permanently. Temporarily it can store because it is either it is on or off. That's the reason. And this RAM will be divided into several memory locations. See, in previous slide, you can clearly see you have ALU, FPU, registered and cache memory. Whatever operations that are belong to integer type, that will be dealt with ALU processing space, memory space. If it is FPU, it is dealt with FPU processing memory space. That's why in Python, for every object, for every operation, there is a specific space will be allocated. That is the reason before you enter into your programming language, you should know the background behind it, how the hardware works in tandem with your programming language or commands. So this is the typical RAM looks like. So similarly, ROM. So our hard disk. So basically now the hard disk is SDD. So but before, the hard disk is of a different type. It is called basically the previous hard disk looks like this. It consists of a disk, and you will have a, what do you call that, platter. So if you look into it, how does this work? In a simple way, see, this is how it works. You have a platter, it's a magnetic material coated, and so when this disk rotates, so when you, if you give some for example, you are processing the word file, you are typing some word. Okay, when after typing that, when you click save, in a certain location, what happens? This is when this is rotating, when this lever, when this lever is touching the platter, that means whatever we have discussed before, it excites the electrons. Okay, when this excites the electron, so that electron can have only two spins, either clockwise or anti-clockwise. See, here you can see one is clockwise, other one is anti-clockwise, clockwise and anti-clockwise. So now if it has a two spins, if it is clockwise spin, it is like 0. If it is anti-clockwise spin, it is like 1. The game is over. That's it. That's how it stores the data. Again, we move to binary numbers, that's zeros and one, everything. See, whether it is a transistor or whether it is a magnetic material, when you are able to give binary instructions, it can be converted. So now what happens here? So the material, the last R bit, if you see the last R bit, if the last R bit is empty, not completely, if it is partially empty, if the shells are empty, in that case, the electrons will have a different spins. So if it has a different spins, obviously you can store the data. Based on this only, our magnetic platter, our magnetic HDD works. So now the latest and the fastest secondary memory is our SSD, solid state disk. This is as simple as that. It consists of a transistors. Again, we are going back to transistors because Magnetic drive is little slower, not little. It's a very slower than SSD because it is all of there are a lot of magnetic components that are involved. That is the reason. So now SSD again you use a transistors. It consists of a plenty of transistors, and that transistors consists of on or off. When you have on or off, again you can store the data. That's how your ROM works. This is how it looks. So now we came into the crux of our learning, that is what is Python. So we have discussed Python 1 as a programming language. So Python as a programming language, what does it consist of? It consists of set of rules to communicate with the processor. That is what we know, because who will process? For example, if you give x is equals to 1 and y is equals to 2, then print x plus y. Then who will do that? This arithmetic calculation. The ALP, arithmetic logical unit, that is present inside the processor will do this. Nobody else. That processor will do this. So if you want to do something with your computer, you have to communicate with the RAM. How will you communicate? For that, one guy made a set of rules. So that is a programming language as a Python. And second one is, now what are these rules? In totality, these are object, expression, statement, module, program. That's it. Now, this is a typical definition you will get everywhere. There is not much to discuss about this. So now, this is a typical example how a Python looks like. See, you have a is equals to 1, b is equals to 3. So you are giving, when you say a is equals to 1, you are telling for now, for present, for this moment, you take a and reference as a reference for object 1. 1 is an object. Okay, 1 is an object. And b, and take reference and save it as a object 3. So now here what is happening is, your whatever data you are typing, that will go into the RAM, and RAM will allot specific spaces for these commands. Then whatever operations you enter, once you click execute, then processor comes into the picture, and then remaining will happen. So now this is one part, Python as a programming language. And what else is there? Python is an application. See, whatever we are learning, those are set of rules. Now, in reality, if you want to communicate with your processor, if you want to do something in your computer, you require an interface or interpreter. That is your Python as an application. So how do you download this? Go to the python.org, downloads, and Python 3.10, you can find it and you can download it. So after downloading, so this is how it will be reflected in your computer start button. So it consists of an IDLE, integrated development learning environment, and it consists of module docs, and it also consists of Python command line where you can directly do some interactive coding, and it consists of a manuals. So this is the image of IDLE. So how does this look like? Okay. So now we have discussed about the hardware architecture, and we have discussed what is Python. So now we'll just have a look into how does Python communicate with your processor through this visuals. So CPU is the core, then RAM, then input and output devices, then ROM. So the game. So now, for example, you are typing your source code. That could be x is equals to 1 or y is equals to 2, anything. And after typing that code, you will save it in ROM. It obviously it goes to the ROM. But while you are typing, but how do you save it? As a .py. So this is called source code. Whatever you type in your computer through input and output devices, through input device using your keyboard. So that will be stored. It's called a source code. It will be saved as a .py. So it will be saved in, for now, for present, it will be saved in RAM. You can see this here. You can see here. Then once you click execute, then the first thing happens is it will be converted into bytecode, and that bytecode will be saved in PyCache folder in your laptop as a .pyc, Python compile.pyc. Okay, so this all processing is done by again CPU. Then once it is done, then the final aspect is your PVM. That's a runtime. So here what will happen? Once it is converted into bytecode, there is an actual interpreter inside your Python interpreter. That's called Python virtual machine. This will convert your bytecode into machine code, means absolutely to zeros and ones. Then CPU understands exactly what you are talking about. So this PVM at the end, it will convert into zeros and ones, and it will be understood by the CPU, and it will completely execute your code. That is how a Python commands will be interacted with your hardware architecture in your PC. So with this, we have completed